Hey everyone, welcome to the Festive Tech Calendar 2025. I'm grateful to be here for another year, especially since I maybe have missed the initial call for speakers. So thanks first of all to Gregor for still getting me in. Thank you for joining my session today on GitHub Advanced Security, where I'm going to take you on a little festive winter walk in the beautiful snowy land, you could say, of GitHub Dependabot, CodeQL, and other built-in security features. I'll start the session with a quick introduction to DevSecOps, followed by sliding through the snow, passing by different GitHub security features, starting from sharing several repositories, security best practices, where you're going to learn about secret scanning, vulnerability scanning, and advanced code scanning. Each topic will have several live demos, as typical in my sessions. So my name is Peter de Tender, originally from Belgium, but presenting out of the Redmond area, close to the Microsoft campus now, where I've been living for almost 4 years. I joined Microsoft summer 2019 as a full-time technical trainer, and what we do is providing Azure and Azure AI and Copilot, and as you can see, GitHub training to our global customers using virtual workshops. Before I moved into the Microsoft role, I was already working as a partner and vendor for them for about 10 years out of my own company. You got my contact details here on the slide, so I would say if you got any questions, don't hesitate reaching out and feel free to connect on LinkedIn as well. So I guess with that, we gotta put on our winter coat, our gloves, maybe snow boots, and let's explore the first section, the what and why of DevSecOps. Now, while DevOps is primarily focusing on collaborative culture between developers and operations teams, the ultimate goal is, I think, automating yourself or basically automating everything. So walking you through this DevOps process, it starts with developers typically writing code, where then code gets validated and gets packaged, and that's typically what we call the build stage or the CI in CI/CD pipelines. From there, the application gets moved into a running state across preferably different environments using like a dev and test, staging, production, and then eventually gets handed over to the operations teams who make sure that everything keeps running. And then from there, you're going to repeat the cycle to make changes, fix bugs, introduce new features. Now, when we reuse this model, it's basically now about integrating security, and that's where we get DevSecOps. So what it means is that we're going to try and integrate as many security capabilities as possible in each and every of the cycles of DevOps. This list is pretty long, pretty extensive, and obviously I'm going to walk you through some of these offered by the GitHub platform. Now, talking about security features, let's keep ourselves warm with GitHub repository security best practices. Building applications usually starts with source control or version control, yes, using GitHub repositories. Now, even on the repo level, there's already quite some security best practices to share. For example, you can use security policies to guide collaborators or maintaining code, set security policies on branches, like what we call protecting main. You could also define policies on organization and enterprise level. Another recommendation is using secret variables instead of storing secrets in code, and I'll talk a bit more about that later on. And then last here is defining repository rule sets, also known as branch policies in other platforms like Azure DevOps. It allows you, for example, to protect the main branch, forcing reviewing and, for example, running a build validation as part of a pull request. While not immediately security related from a secure your code perspective, it is recommended to provide security documentation in your repos. Now, what this means is, for example, adding the traditional README, but then preferably also add a code of conduct and the contributing files, especially for open source projects, but I would also recommend it to use in your private repos if you're using inner sourcing. Another recommendation is also adding the security markdown file, which should contain some project guidelines, how you're going to handle security overall. And I'll show you a bit how this works in the demo, but you can see here it already shows up on the navigator menu once you start creating all those files. Now that's, I would say, pretty much it for the best practices. So let's leave our skis behind for a second and jump into the one horse open sleigh and take a trip into the demo environment and see a few of these features in action. So for this first demo, I'm going to walk you through some of those repository security best practices. Now, I created a sample repo that is publicly available, so you can go in and maybe validate some settings or copy the code and then maybe replicating it in your own environment. So I call this super original, the Conf42 DevSecOps demo repo. Now, one of the first things that we talked about in like security best practices is probably permissions. Now, the first level is a public repo or a private repo. So from there, I assume that's pretty clear. But then next we go in our settings, and over here, since this is a public repo, we might define who can collaborate, who we're gonna invite, and what are some of the other moderation options. So if we move to collaborators, you can see over here that it expects like direct access. It's a public repo, as you can see over here. And down here, I could explicitly invite people who could now collaborate. Now you could think like, wait a minute, Peter, it's a public repo. Doesn't it mean that everyone can just contribute? Well, contributing is not exactly the same as collaborating. So this means, for example, they can manage repos, they can manage permissions depending what permissions you're going to give them. And then underneath the moderation options, I think another interesting one is defining who can perform some code reviews, where maybe limiting users to read or higher access could be a good one. So that's just mainly the user permissions. Another interesting one is, if I go back to my code level, is that, as mentioned in the presentation, GitHub is now detecting that the branch is not protected. So what that means is that basically anyone with the correct permissions obviously could now move in and not taking security into consideration and maybe forcing a push overriding code, which I don't want, maybe deleting the repo or changing anything else that, again, we are not really seeing as a good security best practice. So what we can do is go into protecting the branch. And then from there, we're bumping into that rule sets, or what I call branch policies. I got an extensive multi-year Azure DevOps platform background, still using it, mainly training now on the two platforms, and somehow I still call this branch policies. So what we can do here is obviously, for example, what I would recommend is protect main, and that means we're going to protect the main branch. We're not allowing any bypass, and we're going to identify the target branch. Now, just a little piece of advice here is, you would typically do protect the default branch, but there might be scenarios where if you have multiple branches that, although the main branch should be considered default, that's not always the case. So that's where I would recommend using both default branch and including by pattern, where then I would add the main branch into it. So from here, just adding like main into it would be good enough. If you're wondering what the difference is with the default branch, well, since I do have a few here, if I go into branches, and actually from here, I go into my branch view, this is what we need. For any of my branches, you can see that we can change the default. So right now, my default is up here, and it's the main branch, but nothing would stop me to go in any of my other branches, and then from here flagging it and defining it as the default. So that's where in the rule set, I actually like the two options to not only protect the default, but also protect any other branch based on the naming. Now let me go back to those rules. and show you a few of, I would say, the common settings. So we create a new branch rule set. You could add tagging as well, where the difference is that not every tag is linked to a branch or the other way around. So once we define the setting, as you can see here, by default, we have restrict deletions and block force push. But obviously there are a whole bunch of other options, and it's not up to me to tell you which ones you should enable or not, because I think it's pretty specific. But for example, a few ones that I usually enable is restricting creations, which means that not just everyone can create a new branch, which might not be exactly following the open source mindset, but that might be a valid scenario. And then the other one I like, that I'll talk about a little bit later on, is requiring code scanning results and code quality results. And another pretty cool one, if you're already using GitHub Copilot Generative AI, is automatically requesting a code review. And I'll show you some outcome of that later on, which, by the way, if you do not use GitHub Copilot yet, it's one of those magical tools, I call them in meantime. So I could definitely recommend you to start looking into it. If you have a personal GitHub account, you can enable Copilot for free. If you have an enterprise account, you need to talk to your business and trying to convince them to invest in GitHub Copilot, I would say. Another option that could be pretty useful is back in the settings, moving into the security section over here and selecting actions. Inside actions, you can now create secret environment variables. So pretty cool. Again, we try to avoid having any secrets or any other strings, if you want, inside our code, where you could use traditional variables, which means they're not protected, they're not encrypted. But if you move them into the secret tab here, they will be encrypted. We're almost there with secret recommendations, but the last one I would recommend is creating any of those additional files, where one of the files we would add here is the security. And the way it works is you define it security.md. In here you provide best practices for security, which probably should be a little bit more extensive. You commit your changes. And from here, the nice thing is that now everyone moving just to the repo gets this little link here to your security policy. It's the same for the code of the conduct and some of the other system files. And then down here, you also have the, sorry for that. You also have the security placeholder over here. And again, in open source but inner source projects, I think it's pretty useful to have those. So that's, I would say, hopefully a pretty cool demo for all of you. Quick introduction to some security best practices, permissions using collaborators, the rule sets or branch policies, secret variables, and security markdown file. With that, I'm going to move on with the presentation. Now, as mentioned earlier, this was already pretty full, but there's another pretty powerful feature in GitHub, and that's providing secret scanning. So let's have a look what that is all about in this next section. Now, as you can imagine from the title, this feature allows you to scan your repositories for secret strings. There is a pretty long list of supported partners and platforms, of which secret strings are automatically getting detected. Think, for example, on AWS S3 storage keys, Azure access keys for storage accounts, maybe broader Azure API keys, connection strings, and even from there, even more broad, are secrets like SSH keys and anything else you could come up with that looks and feels like a secret. The GitHub docs do have a pretty long list of which vendor platforms, I would say, are supported and getting detected. Now, by default, the secret protection scans the repo. So basically, when your secret is already in the repo. However, there's a new setting called push protection, which I'll show you in the demo, and that's acting as a better prevention mechanism since it's going to block you from actually uploading code, synchronizing code, committing code into the repo, unless you're going to move it out, and that's everything before the secrets arrive already in code. And you could expect our tour around the demo winter village is not complete yet, so let's fight some, I don't know, polar bears maybe, because they're trying to steal our secrets. So for the secret scanning here, we're back in the repo, still in the same repo as before, my COM42 DevSecOps demo, and we're gonna enable secret scanning. So how does it work? We move to the security tab, and down here, although it's the last one in the list, I always like to start with this one, where now we have secret scanning enabled. You could go into secrets, and then from here you would enable it. Now when you enable it, it's going to offer you the setting to use the push protection as well, and I'll show you in another part what that means. Now if I move into my code, and let me add something, little web app, I go in my index and all the way down, I already have a little string, but it's not 100% secret. This is a GitHub token, where if you do anything with GitHub tokens, they have the GitHub_pad personal access token as the syntax. Where now if I commit my changes, as you can see, I'm using Copilot pretty frequently. It's pretty convenient here because it's already helping me with my commit messages. I try to commit, and now here you can see that my secret scanning found this GitHub personal access token on line 35 in my code. Now from here we could move on with a couple of different settings, which I guess are pretty straightforward. You can flag like it's a false positive, I'm using it in a test, or why not in a demo, right? Or, you know, like, it's fine, I know that I shouldn't do this, but I'll fix it later, which is an interesting one to me because it's sort of bypassing the baseline of having security protection in the first place. So I wouldn't recommend that one, but I can still see like maybe some of you might look into it. And even then, if you do this, I'll fix it later, which means the secret string will go into the repo. I'll talk about some other scanning mechanism later on that allows you to still detect it. I'm not going to save it for now, but I hope that makes sense. Now you might think, okay, Peter, you're editing files from within GitHub directly. Who's actually developing code from this view? Well, maybe you might use code spaces. Maybe you do VS Code. Maybe you do something else on your local machine. So what we can do, and that's the push protection. If I shift to my exact same view, this is the same code, nothing's changing. Well, I could now try and inject, again, that secret string. So I'm going to grab it. I have it here on the side. I move into my index file. I add it in my code somewhere in any possible file, doesn't matter. And then go in my source control. I'm going to sync my changes. And as you can see here, it tells me like, whoops, something is not working. But now if we check the command output, it's telling me here like, whoops, the push feature cannot contain secrets. So instead of trying to update your code from the repo perspective, this is now happening before you try to push, which I think is definitely convenient. So that's, I would say, pretty much it on secret scanning. So showed you the secret scanning, how to enable it, showed you the impact from the GitHub view, little pop-up message warning you with a couple of options, and then showing you the same from the code view in my VS Code as well. So with that, let's move on with the presentation. With that, let me move on to the next section, covering dependency and vulnerability scanning using GitHub Dependabot. GitHub Dependabot is a built-in service for any repos, both public and private repos, which allows for scanning package dependencies and corresponding vulnerabilities. By default, it's using the cve.org public database of known vulnerabilities, but it also relies on GitHub Advanced Security advisory patterns. You can enable Dependabot from the security settings of the repo in basically 2 clicks, a couple of seconds, and after just a few minutes, it's going to provide you a detailed overview after running a pipeline which performs the scanning and then detecting any known vulnerabilities with also showing you criticalities and any possible fix. So you could guess there is yet another demo coming up for this. So this next one is the Dependabot code scanning. So we move again once more to the security tab over here, and we move to Dependabot. As you can see, once we move into the security options, I would enable Dependabot here, and then maybe some other options if you want to use them is the private vulnerability reporting. It's not the scanning, it's pretty obvious out of the naming, it's the reporting itself. So we would move in, enable Dependabot, and from here again we have a whole bunch of options. The ones that I recommend most, and I'll show you a little bit of that, is the dependency graph. Then obviously within Dependabot, it's not just enabling all or nothing, you have a lot of flexibility here. So we would enable the Dependabot alerts, and then it tells me like, oh, pretty cool. We also need to enable the dependency graph, so I don't have to worry about it. We can define specific Dependabot rules, meaning if you don't like to use just the ones you get from the built-in GitHub Advanced Security, you could now add your own rules. You could focus on specific security updates, like as part of pull requests. You can do version updates, and then it's going to integrate some little task that's called Dependabot inside your github.com system folder. So again, pretty flexible. I'm not going to walk you through all options because we don't really have the time for that. But what happens from here if you enable? It's going to trigger a scanning where for now we don't see the outcome yet, but that's where I can switch to another demo repo. And again, it's a public one, so feel free to have a look into it. It's called Dependabot demo. I enabled just the exact same settings a couple of days ago, as you can see, where now if I move back to security, I select Dependabot, this task was already completed, where now it's telling me like, whoops, Peter, in your sample code here, you have a few security issues. The security issue, I'm just gonna grab one of these, is again based on those public CVEs together with GitHub advisory database as well. It usually looks into your development package. It is aware about any versioning challenges or versioning issues. And in this case, it also tells me that there is a potential solution to move up my package version to a later one, and that should fix the problem. Here on the side, pretty relevant information. What is the attack vector? What is the complexity? What is the severity? And if we move down a little bit more, we can see the CVE ID. I'll talk about that in a second. And down here, we could also pick up the GitHub advisory database information. So this specific example, and again, it's just a demo, right? But it's related to command injection in Lodash, which is like a specific package that we used for the demo. And we can list up all the references from different security and non-security vendors. I talked about that cve.org, and if you've never seen that before, let me grab this CVE number. You can do cve.org. In this example, which I used in another demo a couple of days ago to test, was searching for like SQL injection. And as you can see, it's listing up all the 2025 security problems. And obviously it goes all the way back. Since my previous example was 2021 and a specific number here in the sequence, you can also find all details here. So it's partly coming from that public CVE database and then maybe additional information from the GitHub advisory. Last part, if I switch back to my code view and I go into Insights and I navigate to the dependency graph over here. Since we enabled Dependabot, remember it tells me it will also enable dependency graph. It's now not only showing me the individual problematic package, but it's also showing any other dependencies, where for some of you it might also be relevant to export the SBOM, and that's going to give you a JSON file with all details from all your packages. Looks a little bit weird here, but you can say that it's a pretty extensive, detailed JSON file. So pretty useful, pretty cool, I would say. And that's in short what Dependabot was about, at least the part that I wanted to show you in just a couple of minutes. So with that, let's move on with the last part of the presentation, talking about CodeQL. I know it's getting a bit colder, but we're not at the finish line yet. So pull up that blanket a little bit more, since I'll be talking about GitHub CodeQL, a proprietary code security scanning tool coming from GitHub itself. CodeQL tries to treat your repository code like data, starting from creating a database by using queryable data that you can extract from your code base. You can create your own custom queries or rely on a set of standard queries provided by GitHub researchers and community contributions. The scanning is available for most common development languages. With CodeQL, you can detect security issues, coding errors, and using custom queries. Another cool feature is using CodeQL command line already from your development workstation, which means you could run all this before submitting your code into the repo. And there's also a Visual Studio Code extension that I'll show you in a demo. And that means, again, developers can perform scanning tasks even before merging into the repos. It's all about protecting, right? That's the main thing. I'm already smelling that festive hot chocolate, but before all that, let's close our winter landscape tour by showing you how to set up CodeQL in GitHub. And then from there, I'm going to show you a bit of that VS Code extension integration as well. So we're still in our sample repo. I'm just going to switch back to my COM42 example. And what I did here is once more go into security, selecting code scanning, and then here also obviously enabling code scanning. Now what that's doing is actually building an actions pipeline. So we can go into code. If you know a bit about GitHub Actions pipelines, you should know that they're stored in the .github workflows folder, and inside we have a CodeQL. You can modify this because it's following obviously a lot of the traditional common pipeline syntax and use cases. So we have the on keyword, which means it's a trigger, automatic trigger. Whenever we have any of these operations, and you can make this a lot more filtered, not just the main branch, but any branch, or you could also use a schedule task or use the workflow dispatch, and that means it's a manual trigger. Now in this case, again, it's based on the built-in capability. So it means whenever we have some PR push-pull operations against the main branch, we're gonna run the code scanning. Then the code scanning itself, if it's the first time you use it, I would heavily recommend you to look into those details where it's becoming part of a pipeline. This is a separate pipeline, but in a real world scenario, I could imagine that you're integrating the syntax into your build pipeline. When someone is committing code out of a PR, out of the PR review, you would run a CI build pipeline, and part of that is obviously validating code like a .NET run, .NET restore, .NET publish to create the artifact, and then maybe from there integrating the code scanning. Or like in this example, running it as a scheduled task would also be beneficial. Since we talked about some security best practices, one of the things I didn't mention, but inside your pipeline, you could actually also define permission limitations. So in this case, the read action items here means that the pipeline runs cannot change anything in code. The actual scanning is happening a little bit more below, where over here we identify what is the language, and again CodeQL supports most common languages, so you can read through the README here to identify which language you want to scan. And then a little bit more down we have the actual code actions. So it starts with CodeQL action, initializing it, so that's basically recognizing the language, the build mode. And then a little bit further, it's running. I'm challenged a bit with my view. I'm gonna try and zoom in again. Where then after the initialization, it's running the actual code scanning. So that's the analysis. So nothing really different from any other pipeline syntax, I would say. Where then if we look into the actions view itself, we have CodeQL Advanced, and then here you can see based on my operations, like adding my security file, it's triggering and scanning code. If you look inside the code itself, then there's two tasks. Why? Because this sample has two different code frameworks, one for .NET C#, another one for JavaScript, and it's obviously looping through them. And then inside we can see the CodeQL initialize and then performing the analysis and then basically wrapping up. If we look inside the code analysis, it's going to show you the details. And that brings us back into the security tab, code scanning, and then here you can see for the different languages what got detected. And I just like, I would say, a clean or a green view, which means there are no security issues detected, but I was assuming that is pretty straightforward. So you can look into the scanning results. You can open up the more detailed view for any of these, running the queries. And this is where you can see like what code is actually getting scanned. Now what you see here is those QLX files. So those are the query language, code query, CodeQL query language. And the nice thing is that although this is all running from within the GitHub backend, what if we want to move this a little bit more to the left in the DevSecOps story? What I'm leaning into is what if we can move CodeQL to our development workstation? And that's exactly what we can do, where if I switch back to my code application here, this is still from our secrets, so not going to use that anymore. But now I can go into VS Code and installing the CodeQL extension. There's also CodeQL command line. If you don't have VS Code or you don't use the extensions that much, you could do similar tasks using command line. So after installing the extension and navigating to it, it's going to give you a few options like what development language. You already know I'm using .NET C#. I'm going to download a cloud-based, GitHub-based database, which is called a REST sharp, at least for C# code. And it comes with a sample query, and I can pull up some other top 10 repositories if I would like to use that. What I did is navigating to my example query, and then as you can see here, I'm searching for a secret. Not really, I would say, necessary, but just an example where we already know that we have that secret But if you don't have that secret scanning enabled, or you don't have the push enabled, or you flag it as I'll fix it later, which I did in one of my demos, you could now go like, well, I'm going to rely on CodeQL to actually detect it for me. So from here, we're going to run the query. It's probably not going to take all that long. And I could actually navigate to my previous scan in prep for the demo, and you can see that out of the CodeQL database, it's not finding that text string 115 times. It's detected by 115 different pre-built C# queries, where all of them recognize the secret string. That's the main thing. Where the cool thing is that it's not just scanning for secrets, it's scanning for pretty much anything. So you could obviously do a lot more with the CodeQL language. Just wanted to bring an easy example that's probably relatable to any kind of scenario. But with that, I think I'm going to wrap it up to make sure I'm not running out of time too much. But let's switch back to the presentation. Whew, I'm actually quite happy with all this. First of all, because all my demos worked as expected. Now we're close to the end of my session, where I shared info about the DevSecOps concepts, gave you a set of repository security best practices, followed by more detailed insights on GitHub security features like secret scanning, Dependabot vulnerability scanning, and advanced code scanning using CodeQL. I truly hope you enjoyed learning about GitHub security features as much as I did presenting on the topic. I gotta say my apologies for the silly wintry jokes here and there. I'm just trying to keep it entertaining, keep your attention. That's pretty much it. With that, thank you for having joined the Festive Tech Calendar 2025 edition. And even more so, honestly, thank you for having joined my session specifically today. With the holidays approaching, there's a ton of more sessions or some blog posts here and there that you can read through. I think the Festive Tech Calendar elves surely did another great job in finding all that content. Feels like the perfect gift for techie geeks like ourselves. Oh, and before you get too tipsy on that eggnog or maybe too sleepy from all the holiday food, head over to Just Giving page. Why? Because we want you to donate for the Beats and Cancer charity, and we hope to get at least 1,000 British pounds. With all that, I'm going to close out, getting on my skis again and enjoying a little bit of the winter. Happy holidays, everyone.